Hey guys, in this video we're going to be talking about special limits. So the first one we're going to talk about is the limit as x approaches 0 of sine x over x always equals 1. So make sure when you're using these that it's the limit as x approaches 0. If there's another number that x is approaching, you can't apply these special limits. So this one works for a couple different situations. If you have sine x over x, you're good to go. But it also works if you flip that. So if you have the limit as x approaches 0 of x over sine x, that also equals 1. Similarly, it works if you have a number on the x as long as it's the same on the x and the sine x. So if you have the limit as x approaches 0 of 2x, for example, that's still going to be equal to 1 as long as that 2 is on the x for the sine portion as well. So using that information, pause the video and try to solve the example problem. Now let's do it together. So the limit as x approaches 0 of sine x over 5x is pretty close to the right format we need to apply our special limit. The only issue is that we have a 5 down here and we don't have a 5 up here. So what we can do is we can divide out that 5 as 1/5 and then take the limit of sine x over x. So let's go ahead and do that. So if we divide out 1/5, we would have 1/5 times sine x, and then we would just have the x left in that denominator. And our property of limits states that if we have a constant like 1/5, we can move that and put it on the outside of our limit. So let's go ahead and do that. Now we have the format we need to apply our special limit. The limit as x approaches 0 of sine x over x is always equal to 1. So what we can do is substitute that in. We have 1/5 times 1, which means our final answer is 1/5. The next one we're going to talk about is the limit as x approaches 0 of 1 minus cosine x over x always equals 0. So again, note that we're taking the limit as x approaches 0. If there's another number there, this special limit can't apply. So looking at our example, pause the video, take a moment, and try to figure it out. Okay, now let's do it together. So this one's a little bit tricky because there are two problems. First off, we have this sine x that's not supposed to be there for our format, and we're missing an x in the denominator. So we need to take care of those two issues before it's in the right format. So let's start by taking care of that sine x. We're going to do this by splitting up our fraction. So if we have the limit as x approaches 0, we're going to split our numerator and our denominator. So we'll have 1 minus cosine x over 1, and then 1 over sine x. What about that x that we need in the denominator? Well, we can't just multiply in 1 over x because that'll change the value. But what we can do is multiply by 1. So if we multiply by x over x, that's technically 1, right? But since this is multiplication, we can change the order of things. So we can use the x on the denominator that we multiply in, and we can move that over to our 1 minus cosine fraction. So let's go ahead and do that. Now we have the limit as x approaches 0 of 1 minus cosine x, and now we have that x in the denominator. And what are we left with? Well, we took care of the x in the denominator here. So we have a sine x in the denominator, and we have an x in the numerator. So let's put those together. Now we're pretty close to being able to take our special limit. What we can do is use the property of limits, which state that if we have these two things we're multiplying, then we can take the limit of each one separately. So let's go ahead and do that. And then multiply them together once we take the limit. Now you'll notice, once we split them up, we have the format we need to apply our special limit. The limit as x approaches 0 of 1 minus cosine x over x. What is that equal to? Remember, it's always equal to 0. So no matter what this limit is, our answer is going to be 0. Let's go ahead and take the limit though, just for the video. So if we plug in 0, remember from our unit circle that x equal to 0 would put us at 1, 0. So our sine x would be 0, and we wouldn't be able to take the limit anyways. So our answer is just 0. The last one we're going to look at is the limit as x approaches 0 of 1 plus x to the 1x power always equals e. So this one comes in handy when we have an x in the exponent. It can be a little bit tricky to use though, so let's give this one a try. So our first step is to get it into the right format, right? So we have this 1 plus x to the 1x power here, and we need to be applying our limit as x equals 0 just on that section. So the first thing we can do is apply one of our properties of limits that state if we have a radical, then we can take the limit inside that radical. So let's go ahead and reformat that. We'll have our square root on the outside, and then we'll be taking our limit on the inside. Pretty close now, but we have to deal with this too. So we'll use our property that states if we have a constant, we can move that to the outside of the limit. This is the same property that we used in the first example. So now we have 2 times the limit of plus x to the 1x power, all under the square root of 2. Now that we've done that, we have it in the right format. We have our limit as x approaches 0 of 1 plus x to the 1x power. So we can go ahead and substitute our answer. We know it's going to be equal to e. So we have the square root of 2e for our final answer. Now let's take a look at our bonus question. So pause the video, take a moment, and try to figure it out on your own. Okay, now let's do it together. So we have the limit as x approaches 0. Remember, it always has to be approaching 0. And we have sine x times 1 minus cosine x all over x squared. So we have a chunk that looks like we could apply our sine special limit. We're close. We need an x in the denominator. And then we have the same thing for our cosine special limit. And we have an x squared in the denominator. So since both of these need an x in the denominator, we can just split our fraction. So we'll take the limit as x approaches 0 of sine x over x times 1 minus cosine x over x. And then we take the limit of each independently. So we'll take the limit as x approaches 0 of sine x over x. Take the limit as x approaches 0 of 1 minus cosine x over x. Now that these are both in the right format to apply our special limits, we know that the limit as x approaches 0 of sine x over x is always equal to 1. And we know the limit as x approaches 0 of 1 minus cosine x over x is always equal to 0. So our final answer would be 0. Thanks for watching. I hope this helps.